Hello and a warm welcome on behalf of MTI Audio. Maybe you wondered why we are talking about an API solution for noise monitoring, as we are already offering a noise monitoring platform, Noise Scout, for instance, which is working fine. However, there are customers who want to establish their own solution, their own link between a sound level meter like the XL3 to their own monitoring platform, cloud solution, whatever it is. And for this customer, we have compiled the content of this webinar to explain how to do that with the XL3. Here you can see the topics that we will cover in this presentation. We will start with an overview on the API. We will introduce you to the hardware interfaces, also say something about the communication protocols, and then step to the key part of this presentation, the practical part. After that, I will summarize the most important information, add some more hints and tips. My name is Markus Becker. I'm moderating this webinar and I'm assisted today by Thomas Hupp, our CTO. And he is also the one who will guide you through the practical presentation. I expect that the whole webinar will last about 35 minutes, a little bit more than half an hour. So let's start with the overview. API stands for Application Programming Interface, and it's a tool or a set of instructions that allows you to integrate an XL3 sound level meter into your software, into your monitoring platform. And important to know, there are two basic operating modes. We call it the Control API and the Streaming API. What is the difference between these two? Let us start with the Control API. Here we have a controlling PC. We have an XL3, maybe standing beside of it. We have a device under test that needs to be checked or verified. And now you will send a command from the PC to the XL3. The XL3 executes the corresponding task, executes the measurements, and returns the acquired data to the PC. Then you will send another time, maybe the same or a different command for other actions. XL3 executes it, sends back the data. Then maybe there is a pause, and then there will be another command. So this goes on and on stepwise. So always sending a command and receiving the measurement data. On the other side, when we talk about the streaming API, we have a different situation. Again, we have a controlling PC and we are sending a command to the XL3, which is now, for instance, located somewhere in the green field. But now the XL3 by itself will respond by sending in defined time intervals the requested data. So you only have to send once the command to initiate this process. And the XL3 by itself will automatically take care to return all the data that has been requested in these predefined time intervals. That can be 1 second, that can be 5 or 10 seconds, whatever you prefer. So when we talk about the control API, we have this query command that's coming from a software routine, or maybe it's manually triggered. The data from the XL3 would be typically a sound level or a spectrum, maybe even a reverberation time. And the typical application would be a test bench or an end-of-line quality control, something in that direction. When we look at the streaming API, here we have typically a manually triggered initiation, because you just have to do it once at the very beginning of your process. You do that typically for a long time. The returned data would, in most cases, comprise sound pressure level, can be audio files, audio recordings, state of health. So, for instance, the battery charge level, something like that, or the weather data if you have connected a weather station. This is all typical data that has been returned for unattended noise monitoring. This is the key application of the streaming API. And this thing here to the right-hand side, this application is what we talk about in this webinar. Some words about the physical connections, the interfaces. We have a USB-C connector at the XL3 to which you can connect. We can add an adapter so that you can connect the device to an Ethernet. We can use the built-in Wi-Fi, or maybe if you want to transfer the data via mobile data. In that case, you need, of course, a gateway that needs to be connected to the XL3. That is also an option. On the data transfer side, very popular is the NTI Connect platform that we are offering for all customers, for all users of an XL3. It includes an XL3 web server. And through this solution, you may transfer commands from your PC to the device and query back data or from the XL3. This is a free service that we are offering depending on the data volume. If you exceed 2 gigabit per month, then you would need to pay an extra fee, but up to 2 gigabit per month, it is free of charge. Just one more hint, we have already presented a webinar on this topic on the NTI Connect. If you are interested in learning more about that, take a look at it. But Thomas will also give you some more information on that in his practical presentation. Very few words about the communication protocols. We have the TCP, Transmission Control Protocol, for local networks, and that is available for the streaming API by using either of these ports or the control API via this port. I'm just listing that for reference. More frequently used, more comfortable would be WebSockets, and that is what Thomas will show you also in the practical presentation. They are suited for local networks as well as an internet connection. And internet means in this case that your XL3 can be placed far away from your office, out on the field. Here we have also available ports for streaming and control API. Well, that brings me already to the start of the practical presentation. Thomas will introduce you now to the software and the tools that he has installed on his PC, debugger, browser. He has connected the XL3 on his desk via Ethernet. He will show you the WebSocket connection. So it is time to hand over the word to Thomas, and he will now guide you through the consecutive part. I will come back at the very end of the webinar.
Thanks, Markus, and welcome to everybody. For the practical demonstration, we are using the programming language Python. This is just one choice. The API can also be used with nearly any other programming language. For Python in our company, we're using the development environment PyCharm. There is also a free community version of it. It's not necessary that you use PyCharm, but it makes executing and developing Python programs very handy. On the right side on my screen, you see a live remote UI of the XL3, which I have beside me, so that we can see what effects the API calls we are having on the device. I have prepared a couple of demos for you, so let's dive in. First, we want to connect to the device over a WebSocket and query basic state of health data. First question, what is a WebSocket? A WebSocket is a computer communication protocol, and it provides a simultaneous two-way communication between two computers or devices. It is based on HTTP and uses the same ports as a normal website, so WebSocket connections are normally not blocked by firewalls. So whenever a website can be reached, the connectivity over WebSockets or communication over WebSockets is possible. And WebSockets is nothing exotic. It's around us everywhere in the internet. So let's start. What do we need first? We need a library which we can with which we can communicate through WebSockets. Such libraries are available for most programming languages. Then we open a first connection, create connection, and here you see in this example we are connecting over the IP address because the XL3 is in the same network than I am with the PC. So how do we find out the IP address? You go to the XL3, go to the network settings here, and then you find the IP address. In this case, my XL3 is connected by LAN over USB here in this line. Later on, we will use NTI Connect to connect to the device. For that, we will then have to use the connect key, which you always also find on this page. And for security reasons, you have to define a password for the web server, which is also required then for connecting with the API. In my case, this is set to API demo. Good. Next, what we do is after we have done the connection, we see what the XL3 sends to us, and it will send to us a password prompt. It will ask for the password. We will respond with our password. XL3 then will send us an identification message, and we will then ask for state of health data. So let's run it and see what happens. So this is the result. We will get more data in a few seconds or minutes. So the password is this password prompt what we have here. Then we send the API demo password. This is now the identification message, meaning XL3 streaming API, the serial number of the device we are talking to, and the firmware number on the device. This is the identification message. Then we send SOH, and the XL3 responds then with the first header. We call this a begin of stream. It tells us we will send data from this timestamp. You may ask, what is this? This is a so-called epoch time or Linux time. These are seconds, or in our case, milliseconds, since a certain date in the history, somewhere around 1970. This kind of format is very easy for computers to process. It needs less computation power. It's a little bit harder for us to read. If we want to know what it is, we can copy this one. There are many services there where how you can convert it to human readable timestamps. One of these is this epoch converter on this website. You will find this link also in the user manual of the API. Let's copy this in, press time to human date, and you see it's the 14th of December, 17 and 12 minutes. So that's just right now. The device says it will respond to us in an interval of 60,000 milliseconds, so every minute. It provides 13 results to us, and the results are local time, time zone, battery state of charge, and so on. So the results we get from the device is, here it was. That time, a minute later that one, a minute later that one. Now, next line is coming in because every 60 seconds the device is automatically sending this to us. The time zone, the battery is fully charged. Currently, no measurement is running, so the device is stopped. It's ready to start, but has not started yet. We have no weather station connected. We have input voltage on the DC connector of the XL3 of 9.15 volts. The microphone has currently a power consumption on the phantom power of 13 milliamps. This is already a good state of health indicator for the microphone. We have 29 gigabytes free on the SD card and some other information that we are getting in here. So this was now, let's stop this one. This was a demo when we have access to the XL3 in the same network. And I will show you now how we could do the same over NTI Connect. I will just replace one line. I have prepared it here and copy it to our program. you will see the difference. It looks somehow the same. So we create a connection. This time it's a secure WebSocket, WSS. We connect to the Connect NT-Audio COM server, tell the server we want to talk to this connect key. And then again, we have this API and Stream 1. Stream 1 is one of our WebSockets. We also have Stream 2, which we will use later on. And there are other WebSockets for the Control API, which we will show in a further presentation. So let's comment this out and now run it again. Okay, it's not very spectacular because it just gave more or less the same result as before. But what happens is that now my computer connected to this server in which is located in Frankfurt. From Frankfurt, it connected my XL3, which is beside me. My XL3 beside me sent the data to Frankfurt, and from Frankfurt, I got back the data to my PC in the office. Sounds complicated. It's not for you, and it just solves many connectivity issues for you when you are behind firewalls or you do not have a public IP address. So let's go a step further. SOH data is nice, but in the end, we want to have sound pressure level data from the device. So we stop this one here. Yeah. First, a few comments. The XL3 is a generic acoustic analyzer for many applications. And what we now want to do is we want to use it for a special application, which is streaming or unattended noise monitoring. And so we have to prepare the XL3 for this application. An XL3 can be configured with so-called configuration files. These are files you can put to the XL3 and load them, and they describe all important settings of the device in a JSON format. Sounds maybe complicated, but let's dig into such a file. I have prepared it here, API XL3 demo, XL3 configuration. That's the ending of configuration files. Here are the settings which we need to send to the XL3 that we can do noise monitoring. Let's go through them. So JSON is just a structured way of specifying or data in a file. Also, we have main topic, system settings, sound level meter, and subtopics, connections, measurement, under system settings. The first real setting we have is watchdog. It's a connection watchdog, and we switch it on. What does it mean? If for any reason the XL3 cannot connect to the internet for an hour, which is normally not good in an unattended noise monitoring situation, the XL3 tries to de-escalate the situation with a reboot. And it does a reboot twice every 12 hours to do its best to de-escalate such a situation. We have a safe mode, so when the measurement stops, the measurement is saved automatically. That's mandatory, but not so important. Autorun. A noise monitor outside should normally always record data under all circumstances. So I think when you have more than one noise monitor, you do not want to go to the noise monitors and press start there and hope that they're running. With the Autorun on feature, as soon as this configuration gets active, the sound level meter will do everything that it will stay recording data. There are some situations where you have to stop a measurement intentionally. So think about a situation where you have to calibrate the microphone using an acoustic calibrator. You should do this from time to time. So you go out in the field, put the calibrator on top of the microphone, start the calibration procedure on the XL3. For that, you have to stop the measurements. And what we have seen in the past with our noise card system and from with other customers, sometimes customers forget to press start again. And with auto run on, the instrument will automatically restart the measurement 60 seconds after you have stopped operating the system manually. And there are many other situations where this setting just takes care that the XL3 always does its best to record data. There is a next one, folder structure noise monitoring. When you use the XL3 as a normal sound level meter, you normally have projects. You go to a customer and then maybe you store the measurements under the customer's name, or you're going to a building and you will make projects which are called like the building and store the measurements under this folder. Noise monitoring is a little bit different because we have to deal with lots of data. So the XL3, when you run in this mode, could run for months or years. So we could have a huge amount of data on the system. And later on, with the streaming API, we want to retrieve this data from the device. So the device has to find the data very quickly. For that purpose, we store the data completely different when you use it for streaming. So when you have this noise monitoring switched on, we will store the data under noise monitoring, then year 2023, months, and day. So that when we query for data from November, probably this year, we immediately can jump to the right data there. There is another thing with how we record data. This is the file format. If you have ever worked with an XL2 or XL3, you know that we at NTI are logging data in text format. Text format is pretty cool to read, but for a machine like the XL3's, reading its own data is not efficient. So for the streaming API, we started also having a binary format, which is something like a database where we can quickly retrieve data. So this binary format is mandatory for streaming, but you also can select, like we do in this case, give me text and binary format. Yeah, and the last thing we say, we want to have audio, and please give me spectra, EQ, max and min. This is what the device is recording. So now we need to bring this one to the XL3. One way would be to copy this file to the XL3. It's one way to do it. There are easy ways to just do it with the website. But if you have more than one XL3 out, or you have a whole fleet there and you want to put these configurations files to the XL3, it's not handy. So we introduced a streaming API command to just transmit this file to the XL3 and execute it. So that's my next demo. This is the configuration. So in this example, what we do is, you know, these 4 lines already. We do a connection here over the connect server and log in that we get the identification message. The next thing what we have, there is a command called system config, system configuration. Then we can give this configuration a name. In this case, it's the name API demo. This name will later appear here on top. You can give it a meaningful name for your application. And then we are sending the file. To send a file with special characters over the internet, it's not that easy because it has line endings and things like that. So one common way is that you encode the file base 64. So just limiting the number of characters to 64 alphanumeric characters. That's libraries used in the internet very often. So first we have to convert our configuration file here to base 64. That's this routine up here. It's just reading the whole file into a buffer and then encoding the whole to this base 64. How base 64 is looking like, you will see later on when we are retrieving audio, because there we will have lots of base 64 strings. So yeah, then we send this and let's see what happens. So here you see currently sound level meter mode, not running, and this changes now after we have executed this program. Good. So the XL3 is now in the API demo mode configuration, and it has started logging. In this mode, it is ready for us to stream data. So let's go further and extend this example so that we get SPL data from the device. To get data from the device, we have the same file again we had before, and you see we have this reading the configuration in there, create connectivity, and again, we are sending the configuration there. Maybe you would ask, you're sending the configuration twice? Yes, we do. And we also recommend when always you connect to the device, send the configuration to the device. The device is smart enough to decide what to do. If you send him the same configuration as before, it will do absolutely nothing. If we are doing minor changes, like just specifying what we want to see on the display, it just does it on the fly. If we change something major, like we switch the RTA, the spectrum, from octave to 1/3 octave, then the XL3 will automatically stop, load the configuration, and continue the measurement. So always send it. And then this is the next command we want to execute, SPL log. That's the query of SPL data on the XL3. So what arguments do we have to send it? First, we need to tell it from when do we want to have the data. And here, this is again this magic number, this epoch time number. And it could be anything. It could be whenever you have data on the XL3, it could be for half a year or whatever. Just specify the time from when you want to have it. And the XL3 will search for it and start from the closest data it has from there. And what should it stream? We ask him for LAEQ, LAF max, and 1/3 octave ZEQ data. This percentage in Python just means it will replace this part with the now. And now here this is the epoch time from now. And I go back 3 seconds, just that we get a few more lines just when we start the program. And the interface wants to have milliseconds from us, so we multiply it by 1000. Good, and in the end, we just loop through and print whatever the XL3 gives us. We also ask the device for state of health, so expect also state of health be coming in from XL3. So let's start this one. We refresh the page here. Good. Now a little bit more data is coming in. It's getting more exciting. So let's go through it. We have again the welcome string here, the identification string, the OK message for the configuration. And now this is the command we are sending to the device. This is the epoch time string we are sending, a time integer we are sending, and the command. And now it starts responding. So first of all, we get the header, the begin of stream. We call this from the SPL data. So it tells us, I have data for you from this time, every seconds, 1000 milliseconds. I have 38 values for you, LAQ, LF max, and L and 3rd octave ZEQ values. And then from that date, every second, we are getting the right data from the device. In between, we also ask for the state of health data. So here the state of health data header arrived, and here the first state of health data. When we go down and down and down, you see data is just coming in all the time. So maybe you ask about what are these magic numbers here? And I also want to shortly explain this to you. We have, first of all, we are transmitting here SPL log data and state of health data. So you have to distinguish what is it. And this is the second number here, this one. This one is the so-called channel ID. 1 is for SPL log, 3 is for SOH. So whenever you have here a 1, it's SPL, 3, it's SOH. We also could have weather data if we have a weather station connected and we ask for the data. We could have audio data also within there. We will use it later on a other WebSocket, but also SPL report data. What is that? Report data is aggregated data. So the streaming API also could deliver to you EQs over 60 seconds or 5 minutes, or also max values, which are already aggregated over a longer period of time. This would then be the channel ID number 5. The content ID, first of all, the device responded with a header. We call this begin of stream, which is a 2. We see here the 2 and here the 2, which is the header, and then the data, which is 3. There are situations, if I now would press stop on the device, where the device no longer has data, and then it will respond with a 4 end of stream. We will see this later, or just now when we are trying to get audio from the device, we will also see a 4 then. Good. I already told you we want to have also audio from the device. And I want you to notice that we keep this running in the background. And while this is running, I will query audio over a second WebSocket. So I keep this running, open the 5 audio file here, and let's quickly run through the code. We have again the create connection, password prompt, identification message, and then there is the next command we are sending now over the WebSocket stream 2. We can't use the WebSocket stream 1 because the data is coming in here and we cannot open the WebSocket twice. There is only one client for our WebSocket. Here you have the stream 2. Yeah, and we are sending here audio, and we tell again the device from which epoch time we want to have the audio. This could be back for a few days or just a few minutes or whatever. In my case, I'm asking the device, give me the audio which we have recorded 60 seconds ago, and then 3 seconds portion of it. You could choose here 10 minutes, an hour, it's on you. Just the amount of data will be pretty huge. The device will then respond, and the first thing it has to send to us is a response, a begin of stream. So we are getting the response here with these 2 commands, and the first response should be a 2. We are just waiting for that one. And we will then decode what we are getting in there, which is base 60 encoded. We will decode it. So we will get from this string thing, we will get binary data because WAV file is binary data, and store it in memory, which is called WAV file in this case. It's just memory. Then we read again from the device and it will respond with data, and we loop through and it will again respond with data. And in the end, it will go to end of stream, which is 4. And when this comes, we will write what we collected here in the WAV file just to a file which we call WAV, in this case XL3 demo WAV file. And this file then can be played back by an audio player. So let's do it. Already done. I will refresh this view, and we have now here an XL3 demo WAV file. I could double click it and it will play back, but you can't hear it, so it's no use for that. This is the data which we got here. This is the request we sent, and then it comes back. 2 is the audio channel, 2 is the header. So this is how base 64 data is looking like. It's just a mixture of characters, but no special characters in there. That's important. And this decoded base64 gives the binary data we need. So then we have data 3. Down here we have now a 4, which is end of stream, no data anymore. The wave file is stored and done. Yeah, this was done while we queried SPL data, so all in parallel. So here I come to the end of my demonstration. There would be lots of more things which I can show to you, but we are lacking time. So when you're interested or want to learn more about the API interface, I would recommend reading the API manual. It's pretty comprehensive, or if you have questions, just come back to us. Thanks for listening.
Yeah, thank you, Thomas. That was the practical part of our presentation. So let me briefly come back to my own presentation, the slideshow. Just one more slide to be seen. Okay, here we are. So, summary, what is most important to remind of this presentation? First of all, keep in mind these two operating modes, control API for test benches, end-of-line quality control, streaming API. This is the stuff that you saw just now. This is the one that needs to be used for noise monitoring. Very important, if you want to use this API, you need to install the API option on the XL3. And there are two ways to do that, two alternatives. One would be the permanent license. Here we even have the order number, but even if you just call it the permanent API license, we know immediately what it means. So that is the first option you can install. Or another one would be a time-limited version. If you are insecure about what is your best choice, just contact us and we will assist you in finding the optimum solution for your application, for your demand. Then, as mentioned by Thomas, we have a comprehensive documentation about the API, a user manual that is available free of charge for download. You can find it either by logging into the My NTI Audio part of our website that is open to all customers or people who are just interested in our products. And also by using this link, you will find this PDF document free to download. And last but not least, if you are not yet sure whether you really want to go this way, take this step in programming your own platform or integrating an XL3 via the API, we will support you the best possible way for your evaluation. We will be happy to provide this demo code that Thomas showed to you. Just send us an email. We will send it to you. We will support you. And very important, there are a couple of XL3s that we have installed, fixed installations connected to the internet, and they are available for evaluation. So you can connect to these devices, you can see how it works, you can make your own experience, and just in order to come to a solid decision whether this is a good solution for you or not. Well, that brings me to the end of my presentation. From my side, I want to thank you very much for your attention, for your interest. I hope we were able to meet your expectations, to provide the information you've been looking for. And of course, we would be very happy to welcome you at one of our future webinars. For the time being, stay healthy, have a good time. Thank you, and bye-bye.